In this tutorial, we're going to talk about how you calculate the atomic mass of an element. So first we're going to define what atomic mass is, and then we're going to talk about how it's calculated. So atomic mass. Every element on the periodic table has a tile, and in that tile is listed a decimal number, and that decimal number is called the atomic mass. Now you'll notice that, again, it's decimaled, and the reason why is because it's an average mass. It's an average mass of all the known or naturally occurring isotopes of that element. So carbon has 3 elements, carbon 12, 13, and 14, and those are or rather 3 isotopes, and those are the naturally occurring isotopes of carbon. And so that average right there is an average of all 3 of those isotopes. But you'll notice that if you were to take an average of 12, 13, and 14, you wouldn't get 12.011. So why is it 12.011? Well, the reason for that is because it considers 2 things. It considers the abundance, or rather the masses of the known isotopes, but it also considers abundance of those isotopes. And what I mean by that is, which one is there more of? So if I actually round that to a whole number, I get 12. And that tells me that carbon 12 is the most abundant isotope or of carbon. And that, in fact, is true. Something like 98.9% of all carbon atoms are carbon 12s. So here we have the 3 naturally occurring isotopes of carbon, and you'll notice that carbon 12, 98.9% of all carbon is carbon 12, 1.1% of all carbon is carbon 13, and less than 0.1% is carbon 14. So it makes sense that carbon 12's mass makes up most of the average of your atomic mass, so that your atomic mass rounds to 12 because most of the carbon in the world weighs 12. All right, so let's talk about how to make this calculation. So how did they get that 12.011 for carbon, and how did they get the other atomic masses for all the other elements? So in order to do this, we're going to use a different isotope. We'll use the isotopes of nitrogen. So to make the calculation, you're going to need 2 pieces of information. The first is you're going to need the masses of each isotope. And then you're going to want the abundance of each isotope. So that's given to you in this picture right here. Sorry, that does not spell isotope. Okay, so if you look at this picture, isotope, you've got nitrogen 14 and you have nitrogen 15. Okay, nitrogen 14 has a mass of 14.0037, so its mass is 14.00307, and its abundance is 99.63%. So hopefully at this point you realize that the atomic mass for nitrogen is going to probably round to close to 14 because nitrogen 14 is most of the naturally occurring nitrogen. Okay, and then you've got nitrogen 15 with a mass of 15.001 and a percent, or rather abundance, of 0.37%. Okay, so to make the calculation, you are going to need an equation. So here's the equation. So you're going to take the abundance of isotope 1, of your first isotope, and you're going to divide that by 100 to get it out of being a percentage. Then you're going to multiply by its mass. And then the product of that, you're going to add that to the abundance of isotope 2 divided by 100 times the mass of that isotope, plus the same thing for a third or a fourth or a fifth isotope. So let's make this calculation very quickly. So I just moved the equation. So we'll go ahead and we'll take the abundance of our first isotope, which was 99.63%, and we'll divide that by 100. Now I realize that you could probably do that in your head, which is totally fine. Make that 0.9963, and you're going to multiply by its mass of 14.00307, and you're going to get the product for that. And then you're going to add that to the abundance of the second isotope, which is 0.37%. And you're going to divide that, of course, by 100 to get it out of being a percentage. And then you'll multiply by its mass of 15.0001 and get that product. And since those are the only two isotopes of nitrogen, then you're just going to do those two things and get an answer. And when you work that out, you should get 14.007 atomic mass units. All right, so there, right there, is the atomic mass of nitrogen, or the average atomic mass based on the mass of each isotope and the abundance of each isotope. All right, so let's check it. So we'll go look at nitrogen over here, and you'll notice that nitrogen's molar mass, I'll increase that, is 14.007. So now you know how that number came to be. It came to be from this particular calculation, where we took the abundance and we took the mass of each of the isotopes and we added them together. So that brings us to the end of this tutorial on how to calculate the mass, or the atomic mass, of an element from its isotopic data.